Hello everyone, welcome to our part 2 of lesson 4. We will discuss rest of the operators in this video. There are three logical operators, and, or, and not. So if we write and in C, and or not in C, that time we will use some symbol there. And if we write and or not in Python, that time we will write and or not in a small letter. So how and or not works, we will see. Here we will get output 1 when the all value of variable input variable is equal to 1, and in case of OR gate we will get output 1 when any of the variables value is 1. If the all variables value are 0, that time so we will get 0. And for the not truth table, that is we will get output 1 for input 0, and we will get output 0 for input 1. Now using these logical operators, we will write a program that takes a person's age and citizenship status as input and determines whether the person is eligible to vote or not. So, a person is eligible to vote if their age is 18 or above and they are a citizen of the country. And we have to check also whether the person is not eligible or not. And finally, we will print all results clearly. So, let's start. Now, start the program using C. We use code blocks. So initially from line 1 to 10, we just write the problem description and any other important information about the program in the beginning of the program. Then we just include str.h and string.h because we are going to use some library function from str.h and some library function from string.h. Then our execution starts from the main function. We will take actually two input, one is age and another is the citizenship status. So age will take as a integer input and citizenship status will take as a string input. That's why we declare int space age and char space citizen, then 10. That means citizen is a array here that is taking 10 character at a time. So when there are more than one character in a variable stored, that time we will call it as a string. Okay. In line 21 to 25, we are just taking those input using printf and scanf function. Initially, we just taking the age using format specifier %d for the integer number and format specifier %s for the string number. Okay. After that, after the taking the input, we just decide that the person is actually eligible or not. So the eligibility rules was if the person's age is greater or equal 18 and uh, the person is actually citizen, that means he is eligible to vote. So to check his eligibility, we are taking actually two variable. One is eligible, another is not eligible. So in the not eligible, we are using and operator, and we are checking actually two condition at a time. One is age is greater or equal 18, and another is we are just checking the citizenship status. We are taking the citizenship status in the citizen variable, and when we are taking this, we just use strcmp function uh, to check it. with another string. Yes, strcmp is actually a string comparison function which is belongs to string.h. It will just compare between two string. Okay, so when these two condition is true, that time it will give output as 1, and it will store into the eligible portion. If he is eligible, that times the not eligible value will be 0. If eligibility is 0, that time we will get not eligible is equal to 1. So here we are using conditional operator to print in the 30 line it is eligible to vote per vote percent as, that means eligible. If the value of eligible is equal to 1, it will print true, otherwise it will print false. For non-eligibility, just replace the eligible by not underscore eligible variable. Okay, just do it. Not eligible to then percentage, that's okay. So it will be not underscore eligible. Okay, so better okay, this is actually better practice in C, that the variable declaration should be completed at the top of the program. Okay, that's why we just rewrite this. Okay, after that we will actually give explanation. Yes, this condition, a person is eligible to vote if their age is 18 or above. We just copy this and paste it into line 27 as a comment. Okay, 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 there is a actually error I have seen. If we run the program, it will give us an error. Yeah, yes is not within a in double quotation mark. There is opening double quotation mark, but there is no double quotation mark at the end before first bracket. So there should be a double quotation before first bracket in 27 line, after yes and before first bracket. Okay, now if we run the program, it will generate a result hopefully. So after running the program, we take 20 as input, and are you a citizen? We give no. So what will happen? Eligibility will false, because these two condition, one condition is true and another condition is false. That's why he is not eligible. Okay, that's why he is not actually eligible to vote. Now move to the assignment operator. Suppose if you write a equal to 5, that means 5 is stored into a. If we write a plus equal to 5, that means summation of a and 5 will be stored into a. If write a minus equal to a equal to a minus equal to 5, that means subtraction result between a and 5 will be stored into a. If we write a into equal to 5, that times the multiplication result of a and 5 will be stored in a. If you write a divide equal to 5, that means the integer result of the division of a and 5 will store into a. If you write a modulus equal to 5, that means the remainder of the division between a and 5 will store into a. So I think this is very simple, uh, how to use actually assignment operators. In C, there is actually two operator, plus plus. It is called increment operator, and minus minus. This is called actually decrement operator. But in Python, is a there is not such operator plus plus or minus minus, but you can write it by a plus equal to 1 or a minus or equal to 1. That's it. Now consider the conditional operator. Conditional operator actually gives you two results. The condition is true, it will give you a true result, and if the condition is false, it will give you the false result. In C, how you write the conditional operator or ternary operator. Here we see that result is equal to, within the first bracket you have to write the condition first. Here is the condition is a is greater than b. If a is greater than b, so that time the true result will be just after the question marks. That means if the uh, condition is true, a is greater than b, it will show a, otherwise it will show b. In Python, uh, how you write but how or how you use the conditional operator. Here is result is equal to a, you will get the result a when if a is greater than b, when the condition is greater than b is true, otherwise you will get b as a result. Bitwise operator actually works in low level programming. Now we will see how bitwise operators works. Here at first we will see we take a equal to 5 and b equal to 3. So binary equivalent of a equal to 5 is here, and binary equivalent of b equal to 3 is here. So if we perform the operation bitwise AND, it will generate output 1. How we will get that? We just see uh, each corresponding bit of a and each corresponding bit of b. If both bits are 1, the result is 1, otherwise the result is 0. Here we see that the rightmost bit of A and rightmost bit of B is equal to 1. That's why we will get A and B. The rightmost bit of A and B is equal to 1. And all other bits will be 0. Since there are no bit except the rightmost bit is equal to 1 for A and B both. Okay, so this is the bitwise AND operator. For the bitwise OR operator, we'll check the corresponding bit again, and if any of the bits is 1, the result is 1. If any of the bits from A, it can be from B. If there is any one in A or in B, that time the result will be 1. So we see that here is 1 1, that is 1. We see it from the rightmost bit. Okay, so 1 1 is equal to 1 for A or B. Then 0 1, it will be also 1. Then 1 0, it will be also 1. And other bit will be 0, since there is no 1 in either A or either B. Okay, so we will get 7 for A or B is equal to 7. If we perform OR operation, A equal to 5 and B equal to 3, we will get 7. Now come to the bitwise XOR operator. If there are actually odd numbers of 1 at pair of A and B, the result will be 0. The result will be 1. Otherwise, the result is 0. So we see that if we compare 5 and 3, there is 1 1. We will always consider the rightmost bit at first. 1 1. Since there is 2 1, it's not odd number of pair, odd number of 1, it is even number of 1. That's why we will get 0 here. Then 0 1, that means there is a odd number of pair, only 1 1. That time it will produce 1 result. Again we will see 1 0, so it will produce 1 here. For other bits it will produce 0. So for A or B we will get 6. 1 1 0, we will get 6 as a result. Now come to the bitwise NOT operation. If input bit is 0, the result is actually 1. That's quite simple. If there is 0, the result is 1. So if we write not a, we will get, here we see that from the right side, the right side bit is 1. So in the not a, the right side bit will be 0 automatically. So in a, that is 0, that is 1. In a, there is 1, and it will be 0. And all other bits should be 1 in not a, because the first 5 bits of a is 0 here. So in the not a operation, it will be 0 here. Now come to the left shift operation. So all bits move left, each shift multiplies the number by 2. This is the main objective of left shift. So a left shift b, that means 5 is the actual variable. We have to perform the shift operation on 5. How many times? B, the value of b is 3, that means 3 times. We have to perform the left shift operation 3 times. So since the value of a is equal to 5, so if we perform first shift, that time it will generate the result 5 into 2, that means 10 for the first shift. For the second shift, it will generate 10 into 2, that means 20. And for the third shift, it will generate 20 into 2, that means 40. So here we see the binary equivalent of 40 for the left shift operation. Now come to the right shift. All bits move right, each shift divides the number by 2. That means here is the value of a is 5 and b is 3. That means we have to perform the right shift operation on 5 by 3 times. Okay. So at first, if we divide 5 divided by 2 first time, it will generate the result 2. Then again, if we perform the operation, division operation by 2, uh, 2 by 2 is equal to 1. Again, if we perform the operation 1 divided by 2, it will generate the result, the integer result 0 actually in C. So that's why we will get all 0 here for the right shift operation of 5 right shift 3. We will get all 0 here. I hope you will understand all of the things in the bitwise operators. This is actually very much common in low level programming, and it is quite useful.